So, what is a term? In algebra, we're constantly talking about terms, not a school term, but an algebraic term, and these are all examples of terms. The number 7, just a number by itself, is a term. The letter A is a term, although arguably you could have a number 1 in front of it. Now incidentally, when I use a little dot, that means multiply, it means times. But you tend to leave it out if you don't have to put it in. But if you do see it, a little dot, it means multiply. There's another term, it's got 2 letters in it, but it's x times y. Number in front of it will be a 1, but it's invisible, you can't see it. So there's another term. Finally, 3x squared. 3 times x is another term. Minus a half times y, or minus a half y, is another term. It's got letters, it's got numbers, and it's got a sign in there as well. 3ab over 2. So we've got 3 times a times b, all divided by 2, is another term. Minus 4e squared. So let's be certain about what each part of the term is. This is what we call the variable. It's the letter part of the term, and in this term it's an e squared. This is what we call the coefficient. So what is coefficient? C-O-E-F-F-I-C-I-E-N-T. And then terms also have a sign. You'll see the sign if it's a negative, but of course if it's a positive you leave it out. So this term up here, the coefficient will be 3, the sign is positive but I can't see it, and the variable letter part is x squared. Here variable letter part is e squared, coefficient is 4, that's the number in front of the letter, and in this case it's got a minus sign. So once we've established what a term is, we then need to learn how to collect them, under what circumstances we can collect them and when we can't collect them. And this is basically called collecting like terms. Now we saw previously what a term looked like, and here we've got 7a, 7 times a, 2x, 2 times x, minus 3y, it's minus 3 times y, the number 6 and 5m. All example of what we call terms. Now like terms are terms which look like each other. 2a, 7a, 26a, 0.5a, minus 13a, 6.2a and a, or 1a as it is. Why are they like each other? Because they've all got the letter part, the variable, a single a. And each time I've got multiples of it. I've got 2 of them, 7 of them, 26 of them, a half, minus 13 of them, 6.2 and 1. Are these all like terms? Yes they are, because they've just got the single letter x. They've got a different coefficient each time, but the terms are like each other because of the single letter x. Are these all like terms? Well yes they are, because they're just single numbers on their own, no letters involved at all. So unlike terms are terms which do not look like each other, such as 2a plus 3b. So we've got an algebraic expression there consisting of 2 terms. The first term is 2a, second term is 3b. The expression says add them together, but I can go no further. I can't combine them in any way. 2x minus 17y, they're not like terms. 3m plus 2n minus 6p, they're not like terms. So, remember that collecting like terms obeys all the rules of directed numbers that we've previously studied. We know 7 takes 6 is 1, minus 3 plus 5 is 2, minus 3 minus 6 is minus 9, 5 minus 9 is minus 4. 6 minus 3, 3 minus 2 plus 9, 7 minus 4 minus 9, minus 13, and 3 minus 8, minus 5. So let's see how we use this technique of collecting like terms. 8y plus 7 plus 2y plus 8. There are two different kind of terms in there. There's the term associated with the letter y, and there are the single numbers. If I collect the y's together, I get 10y. If I collect the numbers together, I get 15. I've got c's, I've got numbers. I'll collect the c's up. 5c plus 3c is 8c. Collect the numbers together. 7 minus 5 equals 2. Notice that's plus 7, but there I'm taking 5 away. So I've got 5c plus 3c, which is 8c, and I've got 7 minus 5, which is plus 2. Deal with the a's first. 5a minus 3a, 2a, and then I've got minus 6 minus 12, and that in fact is minus 18, so the answer is going to be 2a minus 18. Collect the p's up first. I've got 3p plus 2p, that's 5p, and then I've got minus 7 plus 9, which gives me plus 2. The answer is going to be 5p plus 2. I've got n's, I've got y's, and I've got numbers. The n's and the y's I can do nothing with. The numbers, 7 plus 8 is 15. It's going to leave me with 2n plus 2y plus 15. Now in general, the letters follow an alphabetic path, and the numbers come at the end. 7v minus 7 plus 3v minus 5. Collect the v's up. I've got 10v, and then I've got take 7, take 5, and that's take 12. 10v, take 12. I've got 9b take away 11b to start off with. That's going to be minus 2b. And then I've got plus 7 take 12, and that's minus 5. So I'm going to get lots of minuses or negatives in this answer, and it's going to be minus 2b minus 5. And the last one, collect the s's up. You've got 6s plus 2s, 8s, take 3, take 14, take 17. You might like to pause at this point and then just see if you can do these in your head. Similarly, have a go at these, but maybe write the answers down this time.